Congrats on the first shed. Hey, $10. An embarrassment of riches. I guess so, yeah. Okay. I really want to figure out the answer to this freaking branch cut problem. That's what I want to start the stream off with. And then what's going to come next, assuming that I don't get distracted, which is definitely going to happen. I want to... I don't want to do this. No JavaScript, please. I want to pull together some of the more interesting code that I wrote over the quarter and kind of organize it a bit better. Hey, VR Gaming. But first, I was writing out every single step of this freaking problem. I just want to speedrun it. And get to the actual part where I was struggling with. So on C1, that part of the contour, R2 is measured from here, which means it's measuring an angle of 2 pi. Yeah, okay. I actually have my final here with me now, so I can check the work that I'm doing here against the work that I did during the test. Okay. It's just me mixing it up. I don't know. This is I took a song from my classical music playlist. Oh, I don't know. This isn't really classical. It's just a piano song, but it's a like vibe. It's called Musetta's Waltz by Giacomo Puccini. Competing against... I know. I saw Zach doing that. Well, see, that's why I'm playing this music. You are VR Gaming. Thank you. People are going to be so shocked that this is what they're hearing. They're going to be like, oh, what is this? I better keep watching. It does suck. So the integral on C1 of this bad boy yeah, exactly. The best beard on Twitch. It's been lost to time now, but at one point in my life, I did own a top hat and a monocle. So if that doesn't tell you how classy I am, I don't know what will. Paul's notes chill. No, I'm not playing the stream for super long today, but I know that I'm gonna miss streaming next week, so I'm trying to kind of get in all the stream time I can this week. Ooh, did I miss? Territar, hello. Hope you're doing well. Oh, I might have spotted a mistake I made on the final. It was. I'll show you the original problem. This right here. I couldn't figure out the right answer though during the final, and I've been curious what it's been ever since. Wolfram Alpha does it numerically. I asked the TA, and she said it's something complicated with pi times like something involving root 2. Oh, maybe I didn't miss anything. I was wondering if I needed an extra factor. The notation for how we did this a similar problem is really messy. We call that dx. And I'm not quite following why, like, from dz to dx, we don't need an extra fact. Like, we did a substitution. Do we not need a factor? Oh, 6, 7. Indeed. Eight, 9, Grinch. I would say you need the opening tag too, right? But I think there's some markdown where you only need the closing one. Maybe. I hope this won't be loud. Fair enough. How the Grinch saves this generation. Hey, Aditya. X equals sine theta as a substitution. Oh, I mean, this is a complex variables class. We're supposed to use complex variables here. I doubt it's going to work out if Wolfram Alpha couldn't find that substitution. I mean, you could probably... No, okay, no. You could... if you did a sine substitution, you could do a Weierstrass substitution after that. At the very least. But yeah, that solution method wouldn't fly in a complex variables class. And so really I shouldn't have written theta 1 and theta 2 here. I should have written this theta 1 and theta 2. Hey, Roxra. Oop, put the music back on. What did I do here? The denominator is a little bit weird. I remember I messed this up at first on the final too. I probably need to... what do I need? So this E can come out front. -1 to 1. I want to end up with this. That's the goal. This is a minus sign. So R1, R2 is 1 minus x times 1 plus x. That's perfect. This is 2 minus R1, R2. So 2 minus 1 minus x squared. And I think that works out. Yeah. So we get x squared plus 1. Perfect. That's the original integral here with a factor out front. That's what we want in life. Now we need to repeat the procedure on C3, the other flat part of the contour. And I'm just going to shortcut this because I don't want to write all this out again. At least I got on the final, minus e to the I pi over 2. Minus 1 to 1. Root 1 minus x squared over x squared plus 1 dx. What's due to the do? It's a good question. It's equal to skirtle. Bam! Get wrecked. Okay, and then another thing I don't feel like writing is that the integral on these two circles goes to 0. So we don't have to care about them. What we end up with is the integral around the entire contour. Is equal to the original integral with that minus that. Getting that streak back. All right. Building it up. Thank you for the 3. Oh, I forgot to ask the TA a certain part about this problem, though. Okay, so the thing that remains to be done is to calculate the value around this closed contour using the residue theorem. The issue with the residue theorem is that we're enclosing a branch cut. So how do you deal with that? The proper way is to reverse the contour and think of it as enclosing, instead of enclosing the area inside the contour, we're enclosing the area outside the contour. That's what I was trying to do on the test, but I got confused because you get some sign flipping stuff that's confusing. I also got confused on another part. Which is there's actually poles, the kind that strippers use. There's the function has poles at plus and minus I. And so if you want to reverse the contour, yeah, you have to realize that you're now including those poles and need to subtract them out. I don't know, I was confused on how to actually do that. Okay, so things in the example we did in class, we used binomial expansion, but that's just not really. This is really hard to binomial expand. So maybe okay. First things first. Let's get the residues at plus and minus I. Uh, I don't know what I got yet. Territor on the final, I got 2 pi, which is definitely wrong. I'm trying to get the right answer. That's probably about right though. Wolfram Alpha got like 1.3 something, and so pi is probably around that. So there's a good chance you're right. Oh yeah, this has an issue. I also got confused on this during the final. Because it's square root minus 2. I guess maybe maybe that shouldn't be an issue because we're in complex variable land. Oh, it cancels. Huh. Would you look at that? So on top, we still get negative root 2, right? And then we get minus 2i. The exponents subtract. So root 2 over 2e to the minus I pi? That's not good. These aren't supposed to cancel, but they are. Got the tan equals tan x plus pi and how to solve sine of pi over 12 using sine 8. Oh, that sucks, Lucas. Those are both tricky things. I hope you did well otherwise. Only 1 out of the 23 people thought of that? Oh, God. Well, hopefully you get graded on a curve then. This is so frustrating. Why are the residues canceling? I've been told directly that they do not cancel. Should I be calculating the residue after I do the transformation? I was also confused on that part, I guess. For the rest, all I'm concerned about is that you have at least 6 out of 40 points. Okay. The rest is uncertain. All right. Enjoy your break. Thanks for popping in. Damn it. This is one where I wish I could really just see this worked out in an answer key. Because I feel like I'm doing something slightly wrong here. Once the branch is fixed, you got that it reduces to the residue at z equals I of the integrand. No? Uh, you need to use like, thank you, Lucas. See it. Or at least, I think you need to get the residue at infinity and then subtract out the residue at plus and minus I, and that's your, oh, and then divide out by this factor, and then you have your answer. Wait, these don't cancel, right? This is negative I minus I. Okay, good. Is my error that I'm doing at z equals I and not z equals I 3 pi over 2? Is that an important distinction? Not really. Or is it? No, it's not important. Is it important for the first one? It's not important. I'm so frustrated that I don't know. Uh, how did I get the residue at infinity? Oh, you can just calculate it directly. You don't need binomial expansion. Okay, let me just ignore the plus and minus I part, and let's just get the residue at infinity. Alright, wait. Okay, the integral around CR. CR is like you expand you deform the contour into a giant circle with radius approaching infinity. Is equal to I feel like this isn't even the right thing that I'm about to write. 2 pi I. I don't know how, like, I don't understand how this is supposed to work. 2 pi times the residue of this thing at infinity. So what's the residue of this thing at 0? 0 is a simple pole. Hey, Eldritch. Residue at t equals 0. I think it should just be 1. Yep, get a big fat 1. You know, let me see if the thing that Territar got is actually the right answer. Be helpful to know for where I went wrong. Teratar got pi square root 2 minus 1. 1.30. $1.30129. Teratar got it right. GG Teratar. Then you got it like a bajillion times faster than me, but GG. So the only issue, I think I'm so close to being right. My issue is just that this sign should be flipped, I think. Or maybe this sign should be flipped. What if I get the residue of this at t equals plus and minus I? Those are still simple poles. At plus I, I'm just going to do this mentally. Why can't I think? It's root 2 over minus 2. At minus I... Oh, you need to get it with this? Oh, that's so disgusting. Why doesn't this work? The poles are in the same place. Um... Hmm... I think I'm getting the right answer now. But, like, I really don't get why. $63. Hmm. Damn. This explanation is really lacking. We go to a different textbook. um let's try this one. This problem isn't too far off from the one that we're doing. Four point 3.6. Pac-Man contour. It's not the dog bone. Oh, we need a dog bone. No, this isn't the same. Oh, wait. Is this what we're doing when we expand the integral? I wish he... Oh my... Okay, where's figure 4.3.8? Oh no! Oh, this problem was done in the book. I really wish he drew this during class too. It would have been so much clearer why this giant circle thing works. I remember looking at this problem when I was studying this book over summer and being so confused by it. Hmm. Wait, what? Oh my god, bro. Calculation. Wait, what? Where do you say what the contribution at C, or I guess this is the contribution at CR. I'm so confused. Uh, oh, wait. Maybe, I have no clue how the book is doing it. Maybe I understand where that's coming from, though. I should have been using this. Or something like that. So if z equals I... Dude, you have to use trig here? Like, seriously? To get these angles? The... Slim, thank you so much for the raid. I'm surprised you're done already. I hope it went well. Um, I just working on this contour integral, and I realized that this textbook actually does the entire thing, and I'm trying to understand its explanation. Oh, fair enough. Hope Fiona's well. Last seen playing math. Yeah. I should change that word to streaming math. So that way it applies to both games and to math. I am. I just got to a section of the book that talks about model theory, and I was very confused about everything that it's saying. But aside from that part, it's in like the 40s for the pages, so somewhere in there. So I don't know what to make of that part of the book, but I have to look. I think I'm in the late 40s. All right, I got just to the first page of chapter 3. So I finished 45. Yeah. I didn't really understand any of that stuff. Okay, that's good, because I found the book's explanation a little bit too brief. Assumes a bit too much of me. Okay, I'm really sick of this integral. Um, this doesn't feel like a very fair one to put on a final, but I'm not going to complain too much because I still got a good score overall. Um, what I else wanted to do today is look at some code that I wrote over the quarter. Hard locked. Congratulations. You're definitely first. Knew it. Mm-hmm. Um, I'd like to make a copy of this. Vortex simulation. Should I call it Vortex simulation? Sure. So this is the code that I wrote that makes pretty visualizations like this one. These are like vortexes, so they could be like hurricanes. And this one has like 4 of them right next to each other, and they kind of like merge into one. And I want to change up this code. I want to make it better. So we used finite differences for part of this. And I don't want to use finite difference for anything. Yeah. Also, I want to get rid of a lot of this. I only wanted to make one visualization. What? No. Get rid of that. Uh... So, I want to do this with the, completely with Fourier transforms. And I think homework 5 is going to be a good model to look at here. And actually, instead of using this code, I want to use NumPy's built-in. You watched Veritasium vid. He said speed of light might be different in different directions. It's interesting. I didn't know that. I mean, Veritasium knows more than I do, so I'm not gonna doubt him. I need to look at the original equations again. Calculate the speed of light. So I want to compute this in Fourier space. The issue is that there's a nonlinear term that we need to deal with. My favorite physicist? I mean, I don't know that I really have one. I like E and M, so like I guess Maxwell is a good default. But uh I don't really know. Yeah, I don't know that I have a favorite mathematician, to be honest. Um, I haven't really thought about it much. I don't know, but most mathematicians are kind of assholes. Like I don't really look up to them as people. Zach, thank you for the raid. I hope you're Legoing and the math you're doing before that. I'm seeing a triangle with infinitely many circles in it. Went well. Yeah, to Tizzer, sorry, I was just asked who my favorite mathematician is, and I realized I don't really have a good answer to that question. Like, I guess Euler is a good choice because he was actually a good person, but like I feel like most of the mathematicians that I've learned about are kind of jerks in some way in their life, and so I wouldn't really call the ones like that. I wouldn't really want one like that to be my favorite. All raids lead to me, yeah, and you're long for all of them. $10. Problem I did wrong. Oh, okay. I didn't catch that part. Like Archimedes is a cool dude too. As like he's at least too old for us to know if he was a jerk or not. And he has a lot of really cool stories about him that may or may not be true. Um, so I think he'd be a good choice too. And he seemed like he was ahead of his time in a lot of ways. But yeah, for anyone who's joining, I want to clean up some code that I wrote over the quarter. So the first file that I'm working on right now is dealing with vortex simulations. So I have this pretty visualizations, if you have 4 vortices in a square, they all kind of combine into one and spin around like that. And when we wrote this code, we hadn't learned the best way of numerically solving this, which is completely with Fourier transforms. We only did it partially with Fourier transforms. And so I'm trying to figure out how to update this code to do it entirely with Fourier. It shouldn't be that difficult. It's just figuring out the different, like I need to sort out the operator for an x derivative, the operator for a y derivative, and then deal with this kind of nonlinear stuff, because Fourier transforms computationally aren't very nice with nonlinear stuff. So it's actually worth the trouble of inverting it, dealing with it in not Fourier space, and then converting it back, because fast Fourier transform is just that fast. Okay, and so I wanted to do a test with a NumPy function. Let me open up this test file that I use for random stuff like this. So I want to make sure this line of code was I using n as 2 to the 7? Yeah. I want to see if that gives me the same thing as np.fft.fft frac n. I just want to print the size. Yeah. Thank you for the 7 streak, Rex. $128, starting with 0. Ooh. So we have a difference in scaling, it looks like. I'm glad I checked this. I was just going to change it and send it. Oh, it's because of the coefficient in front. Or is it? Maybe I just need to pass in 20 as the D parameter. Thank you, Rex. Thought I'd mix it up. Is it 1 over 20? No? 1 over 10? It's like half of what it should be. No, that's the wrong direction. 1 over 40? $314. That's not actually quite right. What is this supposed to actually be? Sample spacing inverse of sampling rate defaults to 1. I wish I knew what that really meant. I wonder if it's supposed to be this or one over that. Hmm. That's confusing. I guess we're just going to stick with this code that we provided in class. I wish I could get the built-in function to match the output. I don't really know how, though. Oh my, I'm not showing the right window. Sorry. We're provided this code in class to get the frequencies in Fourier space, and so I guess I'm just going to stick with it. I want to make it so I can get the same output with NumPy's built-in function, but I just can't quite get it right, so... I guess what we're gonna do is looking at this one as an example. Instead of A, B, and C, I'm gonna want a KX, KY, and I'm gonna call it K2. So KX is going to be basically this KX. Same with that KY. So actually, I guess we can actually copy paste this code out. I'm going to be passing in as omega f vec. So omega f is going to be equal to omega f vec dot reshape. And we're doing everything completely in Fourier space, so I'm not going to do any transformations in this function. Actually, why don't I just cut and paste that? I didn't realize that I would need this too. And then k is equal to kx squared plus ky squared. We're going to need that to compute Laplacians. So psi f is going to be equal to minus omega f over k2. We don't need this line anymore. Okay, I need to, one second, I need to get the actual equations written here because we got a few derivatives to keep track of. So we want omega t is equal to I can't have had a sign mistake there. Oh, right. Okay, yeah, there's a built-in minus sign. Is equal to negative psi sub x, as in the partial derivative of psi with respect to x, times omega y plus psi y times omega x plus nu, a parameter, times omega. Laplacian omega. I'm just going to abbreviate as lap. So first off, in Fourier space, I'm going to get each of these derivatives. And then we're going to bring them into, we're going to invert them. So first off, I guess psi x is going to be equal to np dot real np dot fft dot I fft 2 an x derivative. Oh man, how are we defining? Is it I or negative I times kx? I don't remember what definition we were using of the Fourier transform. Positive ik. Okay. So in Python, we use j for some reason. 1j times kx times psi f. Psi y np dot real np dot fft dot I fft 2. 1j times ky times... I can't see because the stupid box is blocking my code. Psi f. Omega x np dot real np dot fft dot I fft 2. 1j times kx times omega f. I really should just be copy pasting stuff, but I refuse. 1j times kx times omega f. Okay. So we've calculated our derivatives in Fourier space, which is the great thing about Fourier transforms. We're taking them out of Fourier space so we can deal with the nonlinear stuff. And then down here, we're going to put them back into Fourier space. So this is going to be minus np dot fft2 psi x times omega y. We want element y's multiplication here, and that's what star does for us. Plus np dot fft2 psi y times omega x. And then the Laplacian part can just stay. The Laplacian, you get a negative sign. So minus nu times k2 times, ooh, times are at for Laplacian though. I don't remember. It should be times. If these other ones were times down here. Wait. Yeah, it's times. I need to actually look at the PDF for where this is a different homework where we had to do this, I think. Let me make sure that the equation is coming from is comparable. Yes, we do have a Laplacian. So I can safely copy what I did in this one. And that is element-wise. Welcome back because you're bored. Omega F. And I did just realize we need to make it into a vector again. Sure. We're an Olympiad question. Yeah, hit me with it. I don't know why I'm doing that. Oh wait, I'll look at that in a second, Lucas. KXKY. Okay, and then next we're gonna have to fix our visualization. I guess we'll do that another time though. This mouse with cheese problem looks awful tempting, but we'll go to 16. Ooh, what are these? I don't need the text. I feel like I need the text for this. Hey, I see staple. Oh, it means stack? Oh, I thought these were actual staples, like you staple a paper. No, I definitely need the text here. I'm going to get the text. Okay, there are angular flat plates and rounded deep plates. Flat plate is 3 centimeters high, a deep plate is 4 centimeters high. Not all plates fit together equally well. The figure below shows the height of every possible stack of 2 plates. How are they measuring height? Oh wait, okay. Uh, this is a weird question. Do we go from the top down or the bottom up? Maybe the bottom up. So, uh, that's a round plate. So at the very bottom, we're at 4. We have a round plate on top of that. So the next stage up, we're at 5. On top of that, we have an angled plate, which is that. So a round plate is 4, which means this difference here is 2. So we're at 7. Okay. Um, so now we have angled with a round on top. That one. That's a difference of 2, is it? Wait, on the bottom it's 3. Yeah, okay, so that goes up by 2, so that's 9. Oh, dude, it's so hard to read the stack. Now we're in angled on top of round, so we're back here. We said that was a difference of 2. Now angled on top of angled. Okay, I got 12. What a weird question this is. I'm gonna look at the answer. Because you're saying it could be B or D. Raven? Yeah, that's basically it. There's no answer? Aww. It's from 2022. I feel like there should be an answer somewhere. See if the auto translate does. Math is nothing wrong. uh oh wait, or is this 2020? Okay, there's two different years in this in the URL. Uh to say, okay, maybe I should look at the actual page. 20, okay. That's what I'm on right now. Go to exercise. I don't know which one. The third? Mmm. So we're in the right column. Vlomcy. Okay, yeah, so we're right there. But they don't have the answers. That's crazy. Uh, oh, don't download something. I hate it when I click on a Google link and it just starts downloading something. I don't think I'm finding the right stuff. That's so annoying. I feel like I did it right, but I mean, I don't know why it wouldn't be solvable. Hmm. This is it's like they're trying to make it a geometry problem when it's really not. Um, well, I don't know what that means to check for sets of two. Like we have to work this out by sets of two. Yeah, that's how I got this 5 here, because it's that 5 there. And from there you just calculate like the increases in height. It's like the next set is angled on top of round. So looking at this, it's 6 centimeters, but you subtract out whatever the bottom is. So I did 6 minus 4 is 2. So since the difference is 2, I took my 5 and added 2. I think that's what they want you to do. I don't really get what they're trying to test you on with this question. Like, this is just weird. $23? Okay. Ooh. What? Just okay. Well, this question I think is equally as bad as the last one. This one it might be worse because this is just tedious. Unless there's a trick there probably is a trick that I'm not seeing. But like you can always bash through this just with good old-fashioned algebra. Raven, these are like Dutch high school Olympiad questions. It is like a Christmas ornament, yeah. So I guess I would go from top to bottom, like, or this is a weird like how. I feel like this question. I could be really mad at this question depending on how they're doing this. I think this notation is actually kind of ambiguous. Also, if we're dividing by x in any stage, we should not be able to have 0 as an answer. The answer, well, I guess, okay. So maybe B and C are right out. I assume R0 eliminates 0. Like, it's all real numbers except for 0. So in theory, only A, D, or E should work. And you could always just plug in and check, I guess. This is a stupid question, actually. No, I'm sorry. This question is bad. We need parentheses, or like this is a big abusive notation. I think the more I look at it. Oh, I see what you mean, Lucas. Yeah, no, actually that's my own stupid brain. I thought these were intervals. But they're just not. That part was my bad. I think this is bad though. Like there is a huge difference between x divided by x, x plus x divided by x plus x plus. These markings all look the same. What is a plus if not a rotated x? Like this is completely different from this. And how am I supposed to know which one of these two they mean with this stupid Christmas ornament? Like, I want to interpret it the first way. The second round is way better? Okay. So, let's just try plugging in 3. 3 over 6 over 9 over 9 over 6 over 3. Hey, your favorite spoon? Yeah, these are like Dutch high school Olympiad questions. Fun question, second round? Okay. I guess division is associative. Or wait, am I just being... Can I do this different ways and get different answers? That's the question I'm really interested in here. Like, let me go divide from like the top down, I guess. 1/2 over 9 over 9 over 6 over 3. 1 over 18 over 9 over 6 over 3. 1 over 81 times 2 is 81 times 2, 162 over 6 over 3. Yeah, I can divide this different ways and get different answers. Because if I instead went from the bottom up and did 3 divided by 6 divided by 9 divided by 9 divided by, this is 2. Like what if I want to, and then what if I did that 9 and that 9? 1 over 2. This is a terrible question. I don't know what they mean by this division. Yeah, I'm kind of lost on that one, Lucas. If you want, we can talk about the second round one. Normally this means this is division and the middle is the real fraction. Like, so that's the important thing, and then this is, well, we still have ambiguity with what these two things here are. Hey, no B. Nowhere good, I think. Whatever line is bigger is the later. The shortest line has the closest connection. Okay, that's at least something to go off of. I don't remember being taught that myself, but like I guess I've kind of used that idea without really thinking about it. So if we could do this one and this one first. X plus, I mean, x plus x is just 2x, so it's really just 1/2. Over 2. And then that becomes 1 over 2 times 3x is 6x. 3x over 2 is equal to 2 over 18x squared? Question mark? This is equal to 1 over 9x squared. And this is where we remember it was equal to 1. So x is equal to plus or minus 1/3. I guess I get C. I guess that does fix the issue of ambiguity. It's Dutch, and because they made it up, syntax error. That's true. Okay. Which one do you want to talk about next? I guess we got the answer here. I'm not happy about it, but yeah. So next, I spent a good few minutes just going off on how I hate the notation. At least the language I don't mind, but this thing I hate. $24. It is Himanshu. There's an order you're supposed to do it apparently. Um, I was very confused by it, and I didn't know the order until Lucas told me. Oh, hey, your series exam today? Can I ask a question? Yeah, sure. We'll do this one first, and then I'll work on yours, and then we can go back to Lucas if he has more. What? The minimum number of numbers. It's one of your favorite questions ever. This is basically 40 factorial. Yeah, minimum amount. So we certainly have to remove all the tens, right? Like 10, 20, 30, 40. Surely 40 factorial is just 4 factorial times 10. Oh god. Oh, that's a more difficult serious question. We'll try it though. Um so I think I guess here's what I'm thinking so far. Remove everything ending in 0. 10, 20, 30, 40. I think that's not negotiable. Things ending in 9 are fine. Because 9 times 9 is 81. Zeros and fives? I guess so, yeah. And we do have an even number of things ending in 9, right? 19, 29, 30. Oh, wait. Do we need to remove one of the 9s potentially? I guess. Ooh. Wait, no, we have 9. There we go. We have 4 9s. Mohammed, the answer is I probably can't do it. If it's an actual like regular Olympiad question, no, I can't. There's a different question I need to do from syntax here after this one. Um, it needs to be like a high school Olympiad level question for me to even have a chance at doing it. The Grange's error term, yeah. It's useful for numerical methods. So can we can we calculate the last digit? Um, like how do we calculate the last digit of a big set of numbers? I feel like we could just take only the last digits of all these numbers and multiply them. I'm pretty sure that would work. So if we did only remove 0s and 5s, we would basically be doing 1 times 2 times 3 times 4 times 6 times 7. I forgot 8. Who even likes the number 8 anyway? Not me. You just need mod 10. So I was about to like get this like and raise it to a power. Ooh, Lucas hitting syntax with the buddy. Buddy? Hold your horses. Wait, the most we can remove is 10. 1, 2, 3, 4, 5, 6, 7, 8. We're already at 8 things that we've removed. Okay, this ends in a 2. That ends in a 4. That ends in a 4. That ends in a 6. That ends in an 8. That ends in a 6. And then we have 6 to the power of 4. I'm basically doing mod 10 here, arithmetic, aren't I? um, 6 to the 4, it's just gonna end in 6. Is it not? So yeah, it's going to end in 6. So if I did 6 times 6 times 6, they're all going to end in 6. So we only can, so I guess the question is, can we get it to end in 4 by only removing one of these digits? Otherwise, the answer is E. Like if it ended in, what would 8 to the 4 be? $64. But no, it's going to end in 6, I think. Yeah, sorry, Mohammed. I don't think I can do that one. Hey, Energy. If you move one of the 2's, you get 8 times 2 cubed is 64. What's up, Energy? I'm trying. I do have this one to work on and another one from syntax, but depending on the question, I can maybe get to it sooner. I'm kind of stuck on this one. I want to get to I don't want to keep syntax error waiting for too long. I don't know. Yeah, I feel like there should be a more elegant way of figuring this part of it out, but I don't really want to do it the slow way. Let me, I think I can quickly answer your question, Energy, which, if you want to find so partial derivatives, or you take a partial derivative for a function that has multiple variables. So like if f of x, y is equal to x squared y, the partial derivative with respect to x, there's 2 common notations for it, like that, or with subscripts like that. You're taking the derivative of x in our example here, and anywhere you see another variable like this y, pretend like it's a constant. So we do the power rule on that x to get 2 times x, and then the y just stays there. And the way that I think of it is like, pretend that y is just a regular number, like 3. If you were taking the derivative of 3x squared, it would become, we do 3, and then the derivative of x squared is 2x, and then come back to 6x. So, like, doing this is very analogous to taking the partial derivative up here. Just instead of, like, 3 times 2x, we have y times 2x. That's kind of the quick way of how you find the partial derivative. reverse. Maybe we need to find a first case to work with, I guess, though. 1 times 2 times 3. That's removing 2 numbers, yeah. Yeah. I mean, I feel like guessing is a valid method of solving questions like this. I think, but when you're under time pressure, especially. What's the theorem for mod when you have powers? Can you just make it like regular multiplication? Theorem for modulo with power. It's not what I want. Oh, I don't want totient. I don't think. Oh, Fermat's little theorem is the one that I was thinking of. Oh, but P isn't prime. We have 4 isn't prime. Okay, I'm not quite sure what to do with this. Yeah, if you leave it as is, you get a number that ends in 6. You do need to remove at least one thing. I just want one more thing, I guess. No, if it ends in a 0, you're definitely bad. Or you're definitely wrong. It's like, I don't like the issue with the method I've done here is that you need to try multiplying it in a bunch of different orders to figure out which one you want to remove. And I don't really want to do that. Yeah, I already removed the 0s and the 5s. Because if they're in the mix, you're just always wrong. Okay, I want to take a look at syntax errors problem because I think it's been long enough. We can come back to the other one. But I just don't want to spend too long on one problem when people are waiting. Um, degree 2. Okay, so the Taylor series for just sine of x equals 0 to infinity minus 1 to the n x to the 2n plus 1 2n plus 1 factorial. So Taylor series is sine of x squared. Oh, yeah, yeah. Um, I guess I'll do that part when the time comes. It's been a minute since I've used that. So this x becomes x squared, so it'll be x to the 4n plus 2. So degree 2 means we take the terms. You got it to be just x squared? Okay. N equals 0. Oh yeah, I'm also getting x squared minus something. But we already have the squared there, so that's ordered. That's T2 already, right? Yeah. So the estimate 0 to 1 x squared dx, that's just 1, right? Nope, it's 1/3. This is going to be a pretty bad approximation, I bet, but Lagrange error bound. Oh, it's the same thing as Taylor's remainder theorem, as I learned it. Let me look at this link instead, because the Wikipedia page always kind of confuses me. Right, and so we take the C to be the maximum value of f over the interval. That's how we do this. Okay, so interval being 0, 1, right. Because, yeah, there's no other natural interval to use, I don't think. Now here's a question. This comes from the n equals 0 term. But is this n the same thing as my n? Right, because I want, what I really want is the x squared to match the x squared, I think. Or, okay, yeah, I guess so. But so, like, the thing we're estimating the error for is of the integral, right? Not of the original series? Like, we want to know how far off this 1/3 is from the true value? Okay. So really, the thing we want a series for is the integral of sine of x squared, right? That's not the worst to get. You can just integrate it term by term. That's how I'm interpreting the wording of the question, at least. They don't give us a point to evaluate it at to get the error. Um, this is weird. We were to use the T2 in the integral. Okay. Because I think we need to do a little bit of like a redefinition here from how this question is phrased, I think. Like, or like there need to be some type of like dummy variable or something. Take the question in the first round math exam, which was the following: p of x to the fourth, 3x squared, p plus 4. Uh, Lucas, what I can tell you off the bat is that, because I don't want to move away from syntax errors question, but the way that you would solve that, yeah, it's basically as syntax said. I would phrase it like slightly different. But if you have, let me give a simpler example: 3x to the fourth plus 2x squared plus 5. You can actually use the quadratic formula on this because it looks close enough to 3x squared plus 2x plus 5. Like you still have your variable is x squared now instead of just x, but that's okay. Oh, really? Okay, then let me not over explain that. Can I just like figure that one out quickly then? P minus 4? Okay. So I guess we want the discriminant to be 0 here. We get a quadratic formula inside of another quadratic formula. Wait. Yes. (16 squared? (16 is 2 to the 4. So that's 2 to the 8. That's kind of a big number. (160 minus 16? 144. That is 400, which is 20. To clarify, absolute value, third derivative sine of x cubed is less than or equal to 20. Okay. So if we add, we get ugh, my brain is slow. Okay, so we get minus a half and 9 over 2, I think, for p. But we need p to be negative coming back to here because there's a negative, because this term is 0 because of how we got p. So, and we have x squared, so we don't want to take the square root of a negative. So we can only take the negative solution for p, which is minus a half. So it cancels with that negative there. So I think there's only one value for p. Which it sounds like you have the right logic, Lucas, but we got different numbers. Yes. Shoot. Syntax. I should go back to your question. I thought I'd be able to do that one faster. Do you have the problem with the denominator? I don't think so. I don't know what problem you mean. Wow, this music is kind of extra. I'm leaving it. Who cares? 2 times p minus 4 can be lower than 0. Uh... You mean like in here? I don't know. I'm sorry, Lucas. I don't know what you mean. Um... Well, I guess... Is that like a universal bound syntax? Or is that just over the interval 0 to 1 for the third derivative of sine? Okay, sorry, Lucas. It's getting time for me to end soon. But I'd like to figure this out for syntax. Computer agrees with that. Yeah, Taylor series aren't too bad. This one's a bit tricky. I'm still confused on what we're estimating the error for. Like, I feel like we're estimating the error for the integral. You too, Lucas. Sleep well. But how do we use T2 to... Oh, wait, okay, yeah. Estimate the integral using T2, then estimate the error. Okay, yeah, so we estimate the integral with T2, then we want to estimate the error. And so the thing we want to use the remainder formula with, I think, is the integral. And so it's really more like the integral is from 0 to x sine of, let's just say t squared. Like, I feel like sorry. I guess this is the function. This is our f in this formula here. Integrating all sides preserves the inequality. Okay. Hmm. Max of the absolute value, correct. I mean, how do we know how to evaluate R3? I guess we're gonna bound R3. What's the point of this? I guess we know the T2s integrate to 1/3. And then in order to deal with this integral, we're bounding it using this remainder theorem. Okay. Now I'm on. Okay, yeah, this makes much more sense now. So yeah, I agree. We do need F3. Um, and so we want a bound from above. I'm just gonna do this like carefully. I'm slightly just worried about signs, I guess. I think I'm worried for nothing though. Yeah, I'm worried for nothing. Well, I guess maybe there's a slight difference. Where it would be better to write it like with individual absolute values. Because I don't know if that's going to make a big difference, but maybe it should make a difference at all. I do feel like you should do the triangle inequality like on this first before using the sine and cosine bound. But I guess it wouldn't make a difference here, would it? When we're plugging in when x is between 0 and 1. Well, so this is 20. We still need to plug it into the formula, right? Like it's less than or equal to 20 over 3 factorial. A is 0. So I guess x cubed? That's what you get to? Okay. I mean, T2 is a pretty crappy estimate. I wouldn't be surprised if it's not a very good I wouldn't be surprised if there's a good amount of error. Well, and once you integrate this... Oh, I guess this is R3. Wait, shouldn't this be R2? Wait, unless our notation is just a little bit different. Or... No, it should be R3. Yeah, I'm just gonna not worry too much about that. Zafiri, thank you for the follow. 808, possible Hawaiian spotted. Yes, sir. Hell yeah. I went to college in Hawaii. Oh, this is where your 5 over 6 is coming from. Okay. I mean, we could check what the actual answer is. We have technology. Um... 0.31. Clonk. Thanks for the lurk. Oh. Okay, that error is like 0.02. Interesting. So yeah, this error bound is pretty bad. You're right, Syntax. Yeah, Zach, this is a pretty interesting question from Syntax error. It's kind of... I've gotten an answer that agrees with Syntax, but it doesn't feel quite right. Like, it's technically valid. It's just not a very good bound. It is possible you were given... Like, it is... I think it's possible this is the right answer. Yeah, I mean, Zach might be able to be like firmer on this than I can. I don't see anything that you've done wrong. Um, so I guess oops. Just to repeat what the process was. We found what T2 is, which is just x squared. We used T2 to get an estimate for the integral from 0 to 1. That estimate is 1/3. And then to calculate the error of that estimate, we started here with the definition of Taylor series and remainders. And we integrated all sides of this inequality. There is the 1/3 here. And in order to get an estimate for R3, because we don't know what it is, we use the remainder theorem. So actually, wait, what are we actually saying at the end of this? 1/3 minus 5/6 is less than or equal to integral 0 to 1 sine of x squared dx less than or equal to 1/3 plus 5/6. Well, that makes it even worse, doesn't it? It's somewhere between a negative value and 1 point something. I don't know that I don't see an error in this. The exam was so weird. It had 5 problems. Those questions 1, 4, and 5. So it took me like an hour each for 2 and 3. It's fair. I've had exams like that. Cook. No, it's just a regular old twin. I should have gotten a twin XL. Because, like, I need to make sure I lay at the top of the bed or else my feet are hanging off. And it's kind of annoying. But, yeah. The music stopped. We'll stop with the piano. I'm 5'11". As far as I can tell, it's right syntax. Like, if you made a mistake, I don't see where it is personally. 5'11" too? Nice. Measured by the government. Oh, yeah. Yeah, it's kind of annoying to be 5'11" because it's not a round number, But I do know that in centimeters it's 180, and that is a nice round number. (180 cm) so sexy. Exactly. 5'11" disgusting. Like, I like with like the stereotype that like girls only want a guy who's 6 feet or taller in America. I wonder if in countries with a metric system, if the cutoff is 180. You know, like 10 feet is better. That's true. 10 feet is, I mean, 10 feet might be a little bit too much, but it is round, not nice and round. I'll give you that. Your average height here. Oh, you are from a pretty tall country. The ultimate criterion for a sexual partner. Not the cutoff. Oh, do you have like a taller cutoff there? That would make sense if everyone's just like taller. Okay. I'm thinking I might want to end the stream because I'm kind of tired. Um, I wish I could give you like a firmer answer to the syntax, but yeah, it's Journal++. And Guitar Freak, hey, welcome in. Sorry, you kind of caught me towards the end here, but I'm gonna yap for a little bit. Dr. Cook, yeah, I'm done with finals. It was all wrapped up last week, and the grades are gonna come out, like the final grades come out tomorrow. I already know two out of three of my grades though, which I did well on the finals. The final for complex analysis, I did way better than I thought I did. A stream reveal of my grades. I mean, I've already revealed one of them. We do our exams in this, really? That's funny. You want the pomp and circumstance though? Oh, like I should like have a red carpet and a host who's like announcing things. Yeah. Because like I can't host it myself. I need someone else to host it and to like call me up on stage. And they'll have the grades in an envelope. Yeah, exactly, Zach. Ryan Seacrest will host. Do I plan on gaming tomorrow? If I do stream tomorrow, it'll probably be gaming. I would like to stream tomorrow. I don't know if I will. As long as I have the energy to, I will. C ±3 grades. That's your estimate with error. That's a pretty good estimate there. So yeah, I'm sorry you just got here, get Guitar Freak, but thank you for like popping in again. If someone's streaming math, we're gonna raid into them. So random question: do you know if your complex sequence goes into analytic number theory? No, neither. Neither of those are super applied as far as I know. No worries, syntax. Our big focus was like using Fourier and Laplace transforms for PDEs. That was like the big achievement of the class. over on Penn Center's channel, they've been doing, I mean, not quite weekly streams, but with some regularity, Penn Center has been collaborating with Color Cone and Academy Visa Ideas to talk about Riemann surfaces. You actually learn how to use complex. Yeah. No, I never mentioned it to anyone in real life that I stream at school. There is a Discord for the department, and I'm in that with my streaming account, so like someone could potentially see that, but the Discord isn't super active. And the grad TAs are amazing. I really liked all the TAs that I've interacted with. I pretty much interacted with all the TAs for my classes, and they've all been cool. No, Energy, I'm a master's student. Oh, dude, do you not have grad TAs? They've been super helpful. It would have been a lot harder to succeed in the class without them. That campus for the first time in a couple of weeks. Guy I'm friendly with thought I had dropped out. Oh no, just grinding at home. Fair enough. Seems our university didn't do that. That sounds rough. Like, one of the professors mentioned that because of like budget constraints, a lot of departments are having to cut TAs, but that my department specifically is making a big effort not to do that. Yeah, it seems like I don't know, my entire department seems like really like good. Like people are really supportive and collaborative. I'm sure there's some like politics and stuff like that happens, but I haven't like at least seen it yet. You have one TA for each of your classes. They're each about 10 students. Oh, that's a really nice ratio. Classes are only 10 students. My classes have been like my smallest class was like 30 something students. It's definitely a budget constraint. Plus our school had a lot of undergrads, so our teaching load was really needed for undergrads. That's fair. I don't even know if they offer an undergrad applied math degree. They might. Actually, yeah, I think they do. I haven't really seen any undergrads like running around though. Wait, do they? Yeah, okay, they do. I don't know why I don't really see the undergrads much. But yeah, it's the grad classes are also um like well TA'd. Yeah, the deadline to apply to continue on for PhD is like January 2nd or something. So one of the things that I need to get on is writing a new basically ask for a new personal statement different from the one that you applied with. So I'm gonna write that probably next week. It's pretty casual though. Like you just need that and that's pretty much it. Like they say if you have someone inside of the department who can recommend you do that. But if you don't have a person inside the department, then like don't bother apparently. But yeah, so I'm applying just to do it. I don't expect to really get in, but that's when you go to campus before leaving for uni or for military syntax, or what do you mean? Okay, yeah. And that's a year, right? One remote statistics exam, but then that's it. Mm. Yeah, they said like they get like 25 or so applicants internally, strictly internally. and they normally accept 2 of them, so the odds aren't great. Half a year to a year, banking on that half. Fingers crossed. Will you be? Do you know if you'll be able to still like watch Twitch streams? I guess like, or are you just gonna like disappear off the internet? Did I dominate my peers in class? I did, Dr. Cook. I twisted their arms, but behind their back, took their lunch money. No, I have no clue how everyone else did. I know that I've gotten good grades, and well, yeah, in at least 2 of my class, and I'm pretty confident I got a good grade in the 3rd. Yeah, and only 2 internally, and then I think they accept maybe like 6 more from external applicants. I know I'm getting in, so who's number 2? Oh, you know, okay, before we wrap it up, we could do one more thing. Which was, I wanted to fix up this Vortex simulation code, and I think I was nearly there. Sexy? Mm-hmm. YouTube keeps auto-modding you for calling it sexy, but it is sexy. I don't know why YouTube is being such a square. You do get time off, or that sometimes they just do nothing all day and sit on their phones. That depends on where they're until you get assigned. That's fair. That makes sense. Oops. np.real of that, and then we want np.fft.ift2 of that. And hopefully this works. Let's just run the code and see what pops out. Oh, you hate to see it. Did I forget to reshape something? Is it my input that I did? I forgot to reshape my input. Ha. Omega 0f vec. Oh, cool. You popped in on Zach's stream? Hell yeah. Send me to the whole year track. I'll switch to civil service. That's automatically year. Sure, so I'd rather spend that time somewhere other than the military. Yeah, I would too. Oh, it helps if I tell what to reshape. Wait. Oh my God. I don't know what I'm doing here. Oh my God. What is this? Omega T equals this. Omega T dot reshape n squared. I really messed that up. Omega 0f dot reshape and oh wait, no, I have big N as a variable here, don't I? Ah, I should pass in N as an argument here. Frickin' Python. Did I do this right? I hope I did it right. I guess we'll find out the hard way. What line is that? Oh, I just need the FFT dot. Did I do it twice? What line is that? Here it is. An argument in computer science land is what you plug into, is like what you give a function, basically. Like a number that you give to a function or an object of some kind. None of us know what we're doing? That's fair. My dad told me this story about the time he was in the military thing, but some fella helped them better approximate some grenade launcher equation and got moved up to some other fancier shit. That's cool. It's raining. Oh, this hopefully doesn't take that long to run. I really should have put a print statement. Oh, that wasn't long. Oh, that's not right. That looks cool, but that's not right. Um, I messed something up. Hmm. That should be KY. It shouldn't make a difference, I don't think, to be honest. In most wording, Gmail, check your spelling grammars. VS Code should do similar checks in real time. There are already tools that does that, like Pylint. It's probably so slow. I mean, it already has like syntax highlighting for certain stuff, like if it doesn't recognize a variable name. I don't know what more you mean by that, Linux physics. Let me. Oh, okay. Uh, I guess that's fair, but once it starts assuming enough stuff, I think that's gonna kind of backfire when your project gets really complicated. Like, I think you're gonna start getting really weird behaviors that's gonna be hard to troubleshoot. I guess it could give you a warning and tell you what it's doing. And I guess a lot of them are integrating AI feedback in there too, which can maybe solve that problem. All right, I don't think that would have fixed it, but let's just see. Maybe it did. Oh, it did! Wow, I'm really surprised that that fixed it. Oh, that looks so cool. I love the way that that looks. This looks, it came out kind of different too. This is my original that I'm comparing it against. It looked like this is way more pixelated though. Now it's working, but why exactly? So this is the back to the new one that I just made. I think this is fine though. Okay. So that's nice. I think we'll leave it there. So I want to clean up some more of the code that I wrote and have like a GitHub for the stream is why I'm working on this code. And so this is a file that'll go on it. I might want to do a second type of visualization, maybe like an actual 3D plot of this. But that might be for later because I kind of am tired of thinking. But yeah, I kind of want to put this code up on the GitHub, and then I also made this from reaction diffusion equations, which would be cool. And also there's a lot more initial conditions that I want to play with. So I want to put that up there, and maybe some other stuff too. I'm not sure, but those are the two like coolest things that I did. Also, Hilliard. I should put up that something with that. Where's my Con Hilliard? Okay, yeah. So like this one was a cool one. This shows how two fluids separate if they can't mix. Basically. So I think that code, some version of that code is worthy of being up there at least. But all right, I think that's gonna do it. So thanks everyone who's been hanging out. I guess YouTube stream will get cut off here. Twitch will look for a raid. So anyone who's hanging out on YouTube, thank you for being here. We'll be back at some point.